Good morning, everyone. Thank you very much for the invitation to present here today. And I'm trying to, there we go. I am filling in for Alan Roberson, who was originally scheduled to give this presentation. I've put together a presentation that I hope addresses the main points that he wanted to cover, and let's proceed. From a disclosure standpoint, I have no conflicts and no external funding sources. And I thought that I would begin by giving you a little brief background on who NSF is, not to be confused with the National Science Foundation. We were founded at the University of Michigan School of Public Health back in 1944. We are a 501c3 nonprofit, and our mission is to protect and improve human health. We develop consensus national standards for products that can impact public health. We do testing and risk assessment, product certification, auditing, advisory services, and training and education. And we do that across the entire spectrum of food, water, air, environment, and health sciences. We are a global organization with laboratories and facilities really around the world. With respect to water, we have a whole series of programs that deal with water, product performance, safety, from the source to the tap and then back to the waste water treatment facilities. And we deal with a lot of aspects of drinking water as they may impact human health. The products that we certify are tens of thousands of different products, and they're located here on our website, and they can be searched by a variety of parameters. For over 20 years, NSF has been a WHO collaborating center working in 3 different areas: water, food, and indoor environments. Our main activity has been in the drinking water area. Our current project is on home water treatment for pathogen reduction, and we were instrumental in helping WHO Water develop its guideline for the evaluation of these systems, and we are one of the 2 test labs that evaluate these products for performance. Other environmental programs that we're involved with: wastewater, ballast water treatment technology verification, and a whole series of other programs, also including sustainability. So, before we can really talk about drinking water, we really need to look at the framework that guides activity across the country, and that's really the Safe Drinking Water Act. It was established in 1974, amended in 86 and in 96. Through primacy, it grants the responsibility for compliance and enforcement to the states, and in turn rewards them with various benefits. The Safe Drinking Water Act addresses more than 100 drinking water contaminants, including lead and arsenic, which is the subject of the presentation today. There are primary drinking water regulations and secondary. The primaries are enforceable, the secondary are advisory, and the chemicals that are covered are microorganisms, disinfection byproducts, organic and inorganic chemicals, as well as radionuclides. Safe Drinking Water Act really only covers public water systems that have more than 15 service connections or more than 25 people connected to that facility. When you break down the water utilities or public water supplies across the country, the majority of them are the non-community water systems, and The community water systems are the ones that serve cities like the one that we are in, San Diego, but what we find is that the majority of them are much smaller. Safe Drinking Water Act mandates certain activity by the utilities, such as consumer confidence reports, reporting on what's in their water. There's cost-benefit analysis for any new standard that is proposed by EPA. There's state drinking water or drinking water state revolving fund, which is to fund a lot of infrastructure activity, operator certification, assistance to small systems, and source water protection. At the bottom here, you see that the majority of water systems in this country, 127,000 of the 156,000, are serving less than 500 connections. That is important from the standpoint that these are the least prepared and capable to provide safe drinking water, both from a cost, training, competency, infrastructure standpoint. And EPA has recognized that shortcoming, and that's one of the reasons that small water systems is a focus for them. In addition to the Safe Drinking Water Act, there are a variety of rules that and regulations that utilities are also required to comply with. And here's a list of them. I won't go through them, but needless to say, the utilities have to comply with these, and for the most part, not funded. And so these unfunded mandates create pressure on the water utilities and having to do more with less. When we look at the results of compliance, how the utilities are doing, you'll see here, primarily with the community water systems, health-based violations, systems in violation, and the populations that are affected. The actual compliance rate is surprisingly high for me, 91%, and that implies that there are a fair number of consumers who are still being exposed to water that does not comply with the requirements of the Safe Drinking Water Act. And this is really across the country. And I put here, if you're interested in seeing how a specific utility is performing, this is a good website, echo.epa.gov, and it's a database that contains the reports from the water utilities, and you can view it by size, type, source, state, the types of violations, et cetera. Now, arsenic, it comprises a small percentage of the Earth's crust. It's the 53rd most abundant element. Common valence forms are 3 and 5. Its toxicity, and this is not a risk assessment presentation, but skin, lung, bladder cancer is reported. It's found both in surface water and in groundwaters, as well as some foods. The US EPA's drinking water MCL is currently 10 micrograms per liter with an MCLG of 0. That's the targeted exposure level. When the arsenic rule dropped the MCL from 50 to 10, at the time EPA's goal was 5, and the utilities battled back and got it to 10. And so, but by doing that, there was a significant increase in non-compliance by the utilities. as a result of this. And so a lot of additional treatment had to be put in place in order to get many utilities into compliance with the 10. In general, surface waters are less contaminated than groundwaters. Centralized systems use coagulation, flocculation methods, and they are generally effective at reducing arsenic levels into the compliance range. Decentralized and individual wells have greater challenges, and there is a provision for recommending point of use, point of entry treatment when the number of connections is less than 120, depending upon, from a break-even standpoint, it seems like if a utility has 120 connections or less, that it's more cost-effective to go with point of use. And of course, this is not a U.S. problem. This is a global problem. And you see here the orange-colored areas where there is a very high probability that the arsenic in the water supply is going to be affected in a way to have an excess of the 50 anyways. And let's see, sorry. So when we look at arsenic, for instance, in Bangladesh, because of the shallow tube wells that were put in place to avoid the microbiological contamination of surface waters, and there are millions of these wells across Bangladesh. There are 22 million persons in that country exposed to 50 microgram per liter or more, and a very surprising and heartbreaking 5 million persons who are being exposed to 200 microgram per liter or more. And so just to give you a sense that this is a problem, it is being addressed, and as more centralized treatment is being put in place. And here is the arsenic map for the U.S., and you see where the heavy arsenic centers are, and those are places where there's a lot of activity around treating for arsenic. Now, getting to lead, which we know has been very, very problematic. Just wanted to show you the decline in what has been considered as safe levels for lead in blood lead levels, and over time we have seen a decrease in what is considered acceptable, I guess, as more data becomes available. But the levels today that are considered acceptable are probably a tenth of what they were 50 years ago. One of the reasons for the decline, we see a decline in blood lead levels over the last 50 years, and then primarily because a lot of laws that have been put in place, including removal of lead as an additive from fuels, and removal of lead from, or banning lead in paint, and a variety of other legislation that has been targeted to removing lead as a source of contamination in our environment, and certainly in drinking water. Historically, lead has been used widely in a variety of products. It is being phased out. The toxicity, well-established neurological development, impairment, high blood pressure, etc. The US EPA looks at lead as a treatment technique, not really an MCL, and its MCLG is 0. The MCL is through treatment technique, which means that under the lead and copper rule, the 90th percentile samples have to be below 15 part per billion. Otherwise, there's a series of steps that they have to take. At the bottom of this slide, you see the series of legislations that have put in place the controls to limit the amount of lead in the drinking water systems. In 1986, the lead ban, Lead Contamination Control Act in '88 that removed lead as a material in water coolers and water fountains, the lead copper rule, which is currently the requirements for passivating the water through pH, corrosion control, et cetera, in order to ensure that lead is not being added to the drinking water. Reduction of Lead Act, which, and this is very surprising to a lot of people, but prior to 2011, the definition of lead-free brass was 8% lead. And so when we look at a lot of the installed fixtures around the country, hundreds of millions of them, and we look at the valves, the meters, the faucets, and the like, 8% lead is certainly not what we would consider to be lead-free. That was corrected in 2011, and the maximum amount of lead in any material, including brass, is 0.25%. And then because of the issues related to Flint and some of the confusion surrounding the sampling and how to evaluate the system for compliance with the lead-copper rule, it is being revisited right now and fully expecting to see a proposal come out this year on a revamped lead-copper rule. When we look at lead in public water supplies and in the home, when you break down the different factors that can impact it, source water is not a significant contributor as far as background waters. It is not highly soluble there. Treatment additives. One of the standards that NSF was asked by EPA to develop is the drinking water additives, chemicals, and whether any of them may contain any of the priority chemicals or heavy metals. And so those are all institution in the state drinking water regulations that they have to comply with these standards. And so it is not a significant impact, low impact. Distribution materials and equipment, a lot of these are, and what we call legacy materials. When we look at flow rates in the distribution system versus premise plumbing, for the most part, the flow is constant in the distribution system, and premise plumbing has intermittent and stagnant periods, and so you get surges going through there. The temperatures are generally cooler in the distribution system than they are in the home. Surface area to volume ratio, that is a significant component when you're looking at extraction rates of lead from different surfaces. Water velocity tends to be slower in the distribution system because you have higher diameter plumbing or systems. And disinfectant has a higher impact in the distribution system. One of the main culprits that has been discovered is lead service lines, and continues to be a source of lead contamination in homes. And so there's more than 1 million lead service lines in this country, and that's just an estimate. When in Flint, when they went to examine where are these lead service lines, they found that their records were not at all reliable. And so they have to now actually go into their front yards or backyards and actually examine the service lines to see what they are made out of. And in many cases, the building owners are reluctant to replace the service lines on their property. And then partial replacement does not usually solve the problem. So moving on to Flint, a major crisis that has really resulted in people getting fired, people getting prosecuted, people going to jail, just a comedy of errors, and a comedy that's not funny at all. But I think it requires just a little bit of background on what was going on in the state of Michigan at that time. If you look at this map, these are the cities that were under emergency financial managers during that time. And not on this list is the city of Detroit that was in bankruptcy. So the governor had dispatched emergency financial managers to a lot of these cities, which included Ecorse, Benton Harbor, Pontiac, Flint, Highland Park, Muskegon, Allen Park, Hamtramck. But really, what was happening at the time was, let's bring the costs of the city under control. And in that zeal, I think some of the concerns of those people who were actually running the operations may have been discounted. The crisis was set off. There were a lot of consumer complaints about the drinking water. It was discolored, it had funny odors, it was irritating people, they were getting rashes. There were a lot of problems as this was occurring, and it was a Dr. Mona Hanna-Attisha, and subsequently in conjunction with Mark Edwards, did a study at her clinic to evaluate the blood lead levels of the kids, and she discovered that there was a very significant increase. And this is 3 charts, one of which is the inner city part of Flint with depopulated areas, old homes, etc. You could see that before and after, the blood lead levels jumped from 2 up to 6. The rest of Flint, where there is newer housing, and newer distribution systems, they ended up with a slight bump, and then the non-Flint areas that were lower ended up with an even smaller bump. So when she published these results, it was incontrovertible, and it was at this point that the media really took notice, and the regulatory agencies, EPA, Region 5, et cetera, stepped in to affect change. But it was really the media that got all over this, that brought national attention, because prior to this, despite the discoloration and the taste and odor and all of that, the state was declaring that the water was safe. And in large part, they were basing it on their sampling methods and their testing, and that turned out to be flawed. So are we surprised that this is happening? No. This is what a lot of the distribution system pipes look like in this country. This is not just Flint. And so this is, a ticking time bomb. But when you look at, what is the composition, this is data from Mike Schock over in Cincinnati, that the majority of the deposition on the inside of these pipes is iron, and you got calcium, phosphorus, aluminum, magnesium, et cetera. But you see lead is down at 0.05% of this. So this is part of the problem, because one of the things that happened when the changeover occurred, and I apologize, I got these out of sequence, when the changeover occurred, that there was a corrosion of, let me, and I apologize for this, that slide is out of order. The reason that this occurred was that the emergency financial manager decided that they needed to reduce the cost of the water, which was being purchased in bulk from the City of Detroit water system. And they decided that they would build their own pipeline to Lake Huron and use the Flint water treatment plant to treat that water. They proceeded, but they didn't have that pipeline built yet, so they decided to use the Flint River as a source, and they fired up their old water treatment plant, and it's not clear, but the corrosion control chemicals were not added based upon a misunderstanding of the lead-copper rule. And it could have been cost, but it was not added, and what ended up happening was the protective biofilm and all these depositions on the inside of the distribution system pipe started coming apart, and releasing a lot of these depositions into the system. So that resulted in the discoloration and the sediment and everything moving through the system. This ended up having an adverse impact on the premise plumbing. Primarily any protective coating that had been on the service lines, lead service lines, was quickly removed and exposed as it was inside of the homes. And so it was a twofold problem. After Dr. Mona Hannah Atisha's report, everybody agreed that there was a problem here that needed to be addressed. A state of emergency was called, and a whole series of activity occurred that led to the WRDA bill passing recently, and it's going to provide $170 million in aid to the city of Flint to help it recover from this. The good part is that the steps that have been taken by Michigan DEQ and EPA Region 5 and the city of Flint have resulted in the lead levels coming back down after the switch back to City of Detroit water. Another thing that happened was a sharp increase in the number of Legionnaire's cases, Legionella infections happening in the state. And you can see here that in the summers of 2014 and summers of 2015, there were sharp spikes in the number of Legionella cases. And a lot of that had to do with the residual chlorine not actually making it into the end of the distribution systems at the taps, et cetera. And so There is litigation going on about this. It's not 100% concluded that there's a causal relationship there. However, it does look like there is a reason to investigate this further. And as I mentioned, the average lead levels since the switchback have decreased to, they are now 8 part per billion on average, which is below not only the trigger for lead copper rule at 15, but the state of Michigan has implemented their own lead copper rule for the state at 10. So one part of where NSF was involved in the discussions with Flint is that filters were being called for, and they wanted filters that had been certified for the removal of lead. Now, not all filters are certified for all contaminants. And so in our laboratories, we challenge the filters for their volumes and their capacities to remove certain contaminants. And in this case, we test filters up to 150 part per billion. Unfortunately, in Flint, a lot of the lead levels were much higher than that. And it turns out that a lot of it was based on the particulates in the finished water. So it turns out that the filters did perform, even when the levels were up to 1,000, the filters were performing in reducing the levels of lead to 1 part per billion or less. The rest of my presentation was really going to be looking at infrastructure and what is involved. The American Society of Civil Engineers gives our infrastructure in water a report card of a D+, with many water main breaks and leaks causing health issues, and it is estimated that $1 trillion is needed over the next 25 years to just bring it up to compliance. And so there are a lot of water utility issues that need to be addressed, and I'll just skip over these. But one of the main, some of the issues that utilities have to deal with are these declining population centers, and which raises environmental justice issues, water conservation, and the whole cost of drinking water and the affordability of water. That's actually causing, exacerbating the problem. There are a lot of other compounds that are being discovered. Agricultural runoff is an issue that's resulting in cyanotoxins, emerging contaminants, including trace pharmaceuticals, as was mentioned in one of the previous discussions. Fracking and drilling, contaminating aquifers, and Legionella, which is becoming more and more prominent these days. A couple of trends just to view. Operating expenses for utilities continues to go up as a percentage of total expenses, and as does their debt. So their capacity to take on debt to implement infrastructure improvements is very limited. And as water use declines, as I said, that exacerbates the problem. So in closing, the key takeaways on this: arsenic is a natural contaminant in the groundwater, and it will continue to be something that we have to deal with. Lead is really lead in our drinking water is really a man-made problem that will eventually be reduced, not in our lifetimes, but removal of lead sources is the solution to that. Infrastructure problems will continue to persist. Cost of drinking water will increase, as will the opportunities to cut corners. And that's where we have to prevent more problems like Flint from occurring. One of the big casualties of Flint is public trust and confidence. And there is, even though the water in Flint is now compliant, and even though the filters that they are using are further reducing the amount of lead in the finished water to less than 1, there's a big reluctance for the residents there to get off of bottled water. And that public trust issue is one that's going to be difficult to overcome. Smaller utilities are at higher risk and will continue to be. And we can expect more self-protection in the way of point of use, point of entry, just not trusting what's coming into their home. They're going to continue to use point of use, and really Flint can happen anywhere. So that's my presentation. Thank you very much.
Thank you.